On.
Hello, everybody, and welcome to our
22.
22. I was good. I was going to go with 17, but yes, and this hour we have Abbie Smith, who you may know. She has appeared on the show before, and she writes the blog ERV on science blogs, where she writes about endogenous retroviruses, and she's also debated some creationists that are the footage is available on YouTube. Sorry for that appalling introduction, but I haven't got enough coffee yet. Even though this is my sixth.
Welcome back, Abbie.
Hi, guys.
So, and I'm just going to say that we're at $3,062, so please keep on donating. Let's get it up to 3,100, get it up to a nice, and keep going. Don't think you can slack off for the donations yet. We're not done. There's still a while to go.
I just got an email notification that we got a donation.
All right, that's great. I will check it out. KItch, I understand you've got a whole heap of questions ready while my lizard's scratching the hell out of me.
I've got different topics anyway. Yeah. That maybe, I'm not too sure, maybe the most topical one I can think of right now is the MERS-CoV in Saudi Arabia. Have you been following that at all, or?
I haven't been following it much. I don't know, 100% of the details going in, but I think I can talk about the generalities of what's going on here. This is a virus that has crossed over from animals. I'm fairly certain it's bats, but don't quote me on that. Let me look it up. And so what happens is a zoonotic event, crossing over from one species to another, is not an easy feat. So, for example, rabies, that's not supposed to be in humans. We're not really its natural host. We're a dead-end host. And so we generally don't have human-to-human transmission of rabies. In the case of HIV, that was a zoonotic event from chimpanzees to humans. And chimpanzees and humans are really closely related. But that crossover probably happened numerous times before HIV finally could get a foothold in humans to lead to the HIV epidemic we see today. And so I think what's happened is we have another zoonotic event here that has spread to a human and perhaps to another human, and it's slowly getting a foothold in humans. And we're hoping to nip this in the bud to prevent, the more it replicates in humans, the better it's going to be at transmitting from human to human. So we need to nip this in the bud. This is another reason why we need to take care of our environment, because as we start encroaching in areas that humans normally aren't, we start encountering more animals. We start displacing more animals from their natural habitat. And so, then we start getting coyotes in the backyard and bats in our attic. But yeah, that's very, very general what's going on in that situation. And unfortunately, at this point, we live in a global society. You can get on a plane in Hong Kong and be in, Buenos Aires 24 hours later. So these rare random events have a chance to have an impact at the global level at this point.
And how easy actually is it for viruses such as these that spread from an animal to a human to gain that foothold to go on to more easier human-to-human transmission?
It's usually pretty hard, and we have probably been exposed to this virus many times over the course of human history, or perhaps we really haven't. We don't know at this point. But it generally is pretty hard for a virus to adapt to a radically different host. So, just, again, my context of HIV where I see things, there had to be a lot of changes in the SIV virus in chimpanzees before it could really do what it does now in humans. The HIV-1 is not SIV anymore. But we really need to stop this. We need to prevent people from transmitting it to other people, keep individuals quarantined, and that sort of thing. So we stop this.
I want to come in. It's a bit of an unrelated question here, Abbie, but it's something I hear in the mainstream media that, like, because we're living such sterile lives, our immune systems are getting weaker. Is there any truth to that claim at all?
It's not getting weaker. Your immune, there's nothing really that's causing our immune systems to not be good. The deal is, your immune system is the best it's ever going to be when you're a kid. Once you hit 18, your thymus, where many of your immune cells live, starts going downhill. And so what's really important is for you to be exposed to a lot of garbage, to dogs eating dirt, to crawling around on the floor when you're a kid, because you get exposed to lots of different pathogens and such, and it teaches your immune system how to fight those pathogens. And then when you're 84 years old, you might still have some immune cells around that can fight those pathogens. If you're just never exposed to these things, then once you get older, your response can be more violent. So there are some diseases, the later you're exposed to them, the worse they are. EBV, mono, if you're, a high schooler on the basketball team and you all share water bottles and everybody on the basketball team gets mono, it's a bad course of disease, but it's not that bad. If you don't get mono until you're 26, 30 years old, it can knock you out of work for months. Actually, I had a really bad experience with mono because I didn't get it till I was an adult either. And then I believe it's measles that's much, much worse when you're an adult than if you just get the vaccine when you're younger. So really what you need to do is let your kids wallow around on the floor, let the dog kiss them on the face, because anytime that happens, like my girls, I tell them, it's like, oh, it's okay, it's like it's building up your immune system. But there's nothing that's making us weaker. We're just not exposed to as much garbage as we were in the past, and that's actually kind of it's a good thing that we aren't exposed to some of that disgusting stuff anymore.
And but also lead to allergy problems as well. Just being this cleanliness.
Well, I think allergies are fun. I have them; they're awful, but they are a misdirected immune response. So your immune system sees, for example, tree pollen, and it thinks your body is under attack from tree pollen. So you start making these antibodies to tree pollen that are totally inappropriate. There's not little tree pollen going through your bloodstream, trying to kill you. It's not a thing. But your immune system is blind. It doesn't know that. So it's viciously attacking this tree pollen. And the response is, we get itchy, watery eyes, we're sneezing, we're miserable. And so the trick, or one of the tricks we figured out to fight these inappropriate immune responses, is to make a different inappropriate immune response. So it's called, what is it called? Allergy shots, I think they call it. So if you're allergic to tree pollen, they expose you to tree pollen IV. And that means that you start making different kinds of antibodies to tree pollen that don't lead to the effects we know of as allergies, sneezing, coughing, that sort of thing.
If you don't mind, KItch, I'll kind of butt in. I don't know if you heard this story. I showed it to you, KItch. You'll remember this. There was a story of some scientist in Japan. He actually grew a new strain of flu virus, and there's people questioning.
Yeah.
I mean, is that such a big deal as the media was making it out, or is that just something that goes on in research?
So I've talked about this before, and the thing I stress is that, yes, scientists are a little kooky sometimes, but for the most part, we aren't idiots. We aren't totally insane. And so what's going on is it's a researcher in Japan and a researcher in the United States at the University of Wisconsin. I have an excellent virology department there. What happens at this point, how we were saying about the zoonotic infections? there are different kinds of influenza, and some influenza likes to replicate in birds. Birds have a certain kind of sugar that influenza needs to infect those cells, very simply. And then humans, we have a different kind of sugar, so we have like human flu. Pigs have both kinds of sugars, so they can be infected by both kinds of influenza. And so sometimes influenza can go from birds to pigs to humans. And that's when we get that bird flu scare that we've been hearing about the past decade or so. And so the deal is, in Southeast Asia, there are people living there in extreme poverty. And so they live with their farm animals. They live with geese, they live with ducks, they're there with birds. And so there were quite a few people, a couple years ago at this point, who were infected with bird flu and subsequently died. So that's not to say that's all because of the bird flu virus. Again, these people are living in extreme poverty, so it could also be, lack of health care and such that led to their deaths. But the point is, we've got a virus that normally replicates in birds, now replicating in people and causing death. So a deadly zoonotic event. And so the concern is that that virus would gain the ability to transfer not only from birds to people, but then from people to people. And none of us, no human, has any immunity to a bird flu. So what these labs did was they developed artificially in the lab a bird flu that can be transmitted mammal to mammal. In this case, I believe it was ferrets. They developed it. This is fantastic because we have developed artificially in the lab a virus that we believe will ultimately evolve on its own in nature. So this isn't some guy wildly, let's make a virus that can kill lots of people. That's not what he's doing. What he's doing is anticipating what is going to evolve out in nature before it actually happens. It is possible. Here's the deal, many roads lead to Rome. So he might evolve this virus artificially in the lab, and we might be able to make lots of vaccines for a virus that could evolve in nature, and then a different virus evolves in nature. But conceptually, I think it's a really astounding idea that we can do something like this. Imagine if we had known that SIV was replicating in primates and it was a potential zoonotic event in humans, and we figured out an HIV vaccine before it ever crossed into humans. I think that is the approach that they're going with. This wasn't a guy just trying to make a deadly virus in humans for fun. There was a point, and I think a really cool point, that is being missed by people who aren't virologists and don't understand almost kind of the imminent danger we are kind of in, because again, there's a huge population in Southeast Asia, poverty, living with their birds, their geese, their ducks, and I really feel like this kind of event is going to happen. The question is there a way we can study this virus in the lab to get a head start on a potentially very deadly epidemic before it occurs?
Okay, KItch, do you want to come in with a question there?
Sure. When I was over in ESOP, there was a discussion on emerging pandemics, and just one of the talks said that the antigens, or the surface proteins or surface sugars, the virus can change these. I just want to keep it. I think I'm probably oversimplifying, but they have one. There's two fields of thought that she presented. One was that the virus has a limited access to an unlimited variety of these sugars, or it has unlimited access to a limited variety of sugars. What do you think of those two ideas?
Do you mean sugars, or just what's on the outside of a virus in general?
The hemagglutinin, as far as
okay, so for influenza more specifically,
yeah.
I don't know so much specifically with influenza, what's going on there. But in the first instance, with sugar in general, viruses like to use sugar. They use it basically like a little cloaking device because viruses come from our cells, our host cells. And so if they coat themselves in sugar, our immune system sees it and they're like, oh, that's sugar. I like sugar. I love sugar. I'm going to leave that alone. So it kind of hides the proteins that your immune system, if that sugar wasn't there, would see it and be like, that's not me. I need to kill that. So HIV in particular is very good at just coating itself in sugar as protection, really. The other thing is how the proteins themselves can change. So not just the sugar, but the protein under it. Because ultimately your immune system does figure out that there's something underneath that sugar and starts going after it. That's a really good question because so far with influenza, it can change that protein a lot and still be an infectious virus because that's why we have to get a new influenza shot every single year. HIV is very similar. It changes that protein under the sugar changes all the time, and that's why we can't make a good HIV vaccine. And it seems like with these particular viruses, that protein can change significantly, and the protein still works fine. It's not the case of, for instance, in humans, we can't change, some of our, hemoglobin. We can't change that very much and still be a live human. We're dead. The protein won't work anymore. But viruses, it seems, have evolved to be able to tolerate this kind of mutation and actually use that high level of mutation as part of their life cycle, part of their survival mechanisms. But some viruses don't. And that's why we can make vaccines to them, because generally it's the protein on the outside that we're targeting with vaccines. So some viruses don't change very much at all. And that's why, we get a couple shots, we take the oral polio vaccine on a sugar cube, and we're protected our entire lives. So it depends on the virus.
I'm just going to read a quick question from the chat here. It's from Bod to Bits. It says, Abbie is too excited about this. Does she have secret plans to conquer the universe with an army of highly trained viruses?
Well, that's the thing. We can do that now, and not the bad stuff, but the cool stuff. Yeah. So one thing I talk about all the time is how we have basically domesticated viruses. We've domesticated these things that used to, kill 90% of the population on Earth. We domesticated them to do our bidding, and our bidding is, curing blindness. Like, there are a handful of diseases that are caused by a mutation in a single gene. Viruses, their whole point is to deliver their genetic material to a cell. So if somebody has a non-functional copy of a gene, and we can get a virus to deliver a functional copy of the gene, there's so many things we can do now. I know many labs at this point are actually using HIV as a gene therapy vector to treat HIV. It's like if you would have told someone in 1985 that HIV was going to be a relatively safe gene therapy vector that would be saving lives, including the lives of individuals with HIV, they would have absolutely thought you were insane. It's insane what we can do with viruses today. But it's absolutely amazing. I think they are reprogramming viruses to do good things is the wave of the future. I love it.
Okay, KItch, I'll let you get back to your questions.
Sure. Actually, one of the, just with antibiotic-resistant bacteria like MRSA, they found in, I think it was Galway actually, sorry, that as its antibiotic resistance increases, its virulence decreases. In HIV, is that similar? Because it's just in bacteria, there's kind of a trade-off between growth rate because they're changing the active sites a little bit, and that's going to affect the activity. But of course, usually. Is HIV the same, or is that?
Yeah, usually. Again, I can't say all the time, but usually that is the case. And so that's really why anti-HIV therapy works, and why back when we had AZT, the very first drug against HIV, we gave people that one drug, and their viral loads just tanked. People started getting better. We thought, this is the end of AIDS. We've got a drug for it. But what happens is HIV is not just HIV. HIV is a population of viruses that have the same average, but every virus is a variant off that average. And so what happens is you give someone a drug, and there are already variants in that person that are resistant to the drug, just by chance, because it was just making mistakes here and there, and there are a handful that have the necessary mutations to escape that drug. And generally what happens is that, yes, there is a fitness cost to escape from an antiviral medication. So that initial escape variant doesn't replicate fast, it doesn't replicate well. But what happens is that one virus starts making little mutations off the average again, and ultimately it will stumble across mutations that regain fitness. They're called compensatory mutations. And so it's not only able to escape the antiretroviral, but it's also highly fit. And so we gave these people AZT, their viral loads tanked, and then several years later, several months later, it depends on the individual, the viral loads pop back up, and they're full of virus that can resist the drug. And so that's why we do the combined therapy. We give people at least 3 drugs at the same time. So then the viruses that are still replicating in that individual are much less fit, because they aren't resistant to one antiretroviral, not 2, but 3 antiretrovirals. And it's got to figure out how to regain fitness from that point. And in many patients, it does. HIV as a population is terrifyingly efficient at what it does. But yes, generally escape from an antiretroviral does come at a fitness cost, and we capitalize on that, but we can't hold it off forever.
And can HIV become dormant in hosts?
Sure. Individual viruses will become dormant in individual host cells. So the virus itself isn't individually dormant. It will infect a cell and then chill out. So I'm just going to sit there. It doesn't cause any trouble. It doesn't do anything. And that's ultimately the problem with many of our therapy or newer therapy approaches, in that, you think you get rid of all the virus, and then those quiet guys wake up again and the virus is back. Okay. And studying, it's called latency. Studying HIV latency is in how to wake up all the viruses at once is a hot topic in HIV research right now. And it has been for a while. It's an extremely difficult area to study.
Just to interject there with regards to the donations, somebody, they're willing to donate and they're wondering if you will match their donation. How much are you willing?
Well, it depends on how much it is. I don't have a ton of cash, but I can match a part. Yeah.
So what shall we say?
Well, I could do like 50. I'll do 50.
There you go.
Next, can they do 50?
Yep, next $50 and Abbie will match it. So there you go, guys. Get donating now. So that's motivation. And there was one question from the chat room there. I'll get to that one. They were asking, what do you know about the bubonic plague? I don't know if there's...
I think I know what they're talking about.
Yeah.
So there was some suggestion a while ago, a few years ago, that a mutation that was associated with survival of the bubonic plague is also associated with protection of HIV. And I think what ultimately happened there, it was just sort of a statistics trick. It wasn't ultimately a real connection once they started digging into it. But I think what they're talking about is some people have a mutation in one of the co-receptors that HIV needs to infect cells. It's not the only co-receptor HIV can use, but it's the dominant one. And so many people, if they have a mutation, and it's called the CCR5 gene, are more resistant to HIV infection. And there was some suggestion that that was associated with a population that survived the plague. but I'm not sure whether that ultimately panned out as a genuine connection or not.
Okay, KItch?
Sorry, I was just trying to. I had a question. I just wanted to just make sure that the basis of it was sound.
There was one thing, Abbie, I've been recently reading Craig Venter's new book, where he talks about the
I didn't know we had a new book.
Life at the Speed of Light.
Book?
Yeah, Life at the Speed of Light, it's called, and there was a concept in it.
I didn't know he had a new book.
He was talking about being able to 3D print like bacteria and things like that. Have you ever? Is that something you've heard about, and do you think that'd be an exciting new development?
I don't know about 3D printing bacteria. We do have something called synthetic biology, where we can basically write a DNA code that we're interested in. And that's what Venter's lab did, I believe, at one point. They wrote the DNA for bacteria. So many times what I'm doing in the lab is not generating this information from scratch. I will use it as a DNA as a template to make more of that DNA, but I'm not sitting there writing ATCG. But we have the technology to do that sort of thing now, and it's actually getting pretty cheap. It's cheaper to write a DNA code that you want than it is to do it the old school way that we've been doing it for 30 years. It's some people say, oh, it's terrifying that terrorists can write the genetic information for, I don't know, that influenza virus the guy made or something. I think that's dumb. It's a very expensive technology to start out with. You have to have highly trained individuals to actually run the technology. We have technology to kill lots of people. We have bombs. We have guns. I think that would be a lavish trick for a terrorist to do instead of just, putting some explosives in their shoe. That's been the main concern with synthetic biology, is that someone is going to do something evil with it.
It's not exactly the easiest thing to do in the world.
It's not. It's I think it's overly expensive and overly complicated when we have easy, cheap ways of killing people, if that's really what you want to do.
Yep. All right, KItch. There's a chat room question from Bod to Bits there.
I see it there. Bod to Bits asks, does Abbie ponder the issue of population growth regarding combating fatal disease?
Let's say we cure AIDS tomorrow. Super. Well, now we've got, this huge population in Africa that, now they aren't going to die. They need jobs. They need food. They need shelter. What are you going to do? All you can do is make people's lives better. They say one of the best things to curb population growth is to really educate individuals. The more educated a person is, the fewer kids they have. So, educate individuals, make their lives better, get everyone access to birth control, that sort of thing. But that's not my focus. My focus is helping the people who need help now. Modern humans do not participate in Darwinian medicine. I'm not going to look at a kid infected with HIV and say, population growth, sucks to be you. That's unempathetic. If I was that child, I would want someone to help me. And so we have to figure out other long-term solutions to population growth that don't involve letting people die.
Okay, KItch, there's a few more questions coming in there in the chat room.
Okay.
Yeah, they're in the Skype chat there.
Oh, okay. There we go. Okay, that's there we go. From Dimitri. What exactly would be an example of something evil that could result from this work? I assume it's the work on the influenza virus. Or the bird flu.
Well, I think the main concern, I've seen a lot of alarmist responses from even other scientists to this kinds of research. We do research with smallpox. We do research with deadly, terrifying organisms, and we control them. It's in highly secured facilities. There are certain protocols that we follow so no one accidentally gets infected. With HIV, no one has gotten infected in the laboratory with HIV in decades. The individuals who were infected were generally working with non-compliant prison populations, or were so far back in the day we were using glass in biohazard facilities, and a glass would shatter in their hands for whatever reason and expose them to a lot of virus. So I think the concern would be that someone would get infected and then go home, go to the grocery store, go to Walmart, and expose other people to the virus, that it would escape the lab. Or that somehow, again, a terrorist organization would see this information and decide that they were going to invest millions and millions of dollars in manpower to generating this virus artificially. And I just don't think that's reasonable. I think it's far more likely, because we've seen it, that the virus is going to evolve in nature naturally. It's not a matter of if, but when. So I haven't been overly impressed with some of the alarmist responses I've seen from non-virologists.
Cool. And we have another one from Mechanic 1C. Do vaccines have any negative side effects? Are there any legitimate reasons why someone wouldn't get a vaccine?
Sure. So some people are allergic to stuff that's in a vaccine. We grow influenza vaccine in eggs. If you are allergic to eggs, do not get a shot influenza vaccine. That's bad. Don't do it. There are alternatives. You can still get different influenza vaccines if you're allergic to eggs. But yes, there are some people who are allergic to ingredients. There are some people with compromised immune systems. So some of the viruses we get in vaccines aren't dead, or they aren't just chunks of viruses. They're just weak viruses. So those of us with normal immune systems fight those weak viruses off just fine. But if you have a compromised immune system, if you're going through cancer therapy, something like that, then you should not be getting a live weakened virus, because a weak virus could still be very bad news for someone in that situation. Otherwise, random chance things can happen. I think the side effect that worries parents the most is when their kids get a really high fever after they get a vaccine. And some kids get a super, super high fever and can have a seizure, and that's super freaking scary. But there aren't any long-term effects after that. The comforting aspect of this is that a fever is a sign that your immune system is responding to the vaccine. So it's actually kind of good news. Like if your kid gets a little fever after they get their shots, because you want the kid's immune system to fight it off. Because if they are, these dead viruses or just chunks of viruses, technically they can just float through your immune system for a while, and eventually float through your blood system for a while, and eventually they'll degrade on their own. And so that sometimes happens too. It's like you get the vaccines that you're supposed to get, but your immune system kind of ignores them. And so then you aren't protected as well as you think you are, because you're like, I got my MMRs when I was a kid. So if some dingleberry who doesn't get their vaccines gets measles and comes back home, I'm not going to get sick because I've had my vaccine. That's not always the case. And you won't know until you get exposed to one of these jerks and get measles that you didn't have a very good immune response to the vaccine. But yeah, as to ultimately huge side effects, people dropping dead after they get the HPV vaccine, or getting autism after they get the MMR, things happen. A happens, then B happens. That doesn't necessarily mean that B is caused by A. So I think, ultimately there was a recent review of thousands and thousands and thousands of vaccine trials, and there's just really nothing that comes up as a huge red flag. I get my shots whenever they're due, whenever they're needed. I don't unless you're allergic to an ingredient or have a compromised immune system. There's no reason you shouldn't. Especially if you've got babies popping up in your family, make sure you get a whooping cough booster. That's something we don't think about, but it's really easy for us to get a booster as an adult to not accidentally expose baby to whooping cough. Influenza, if you've got babies in the family, definitely get your influenza shot that year, because you don't want to hurt someone else's baby or your own.
Okay, just to interject there, someone has stepped up to the plate. We just got a $70 donation, but you just match the 50 and that'll be fine.
Sure, yeah.
All right.
So what are we at now?
We are at $3,152, so why not, let's push for 3,200 by the end of this hour and really get things going. And there was something else I was meaning to say. Yeah, we are on the front page of the Vaughan streaming site, so for those of you on the front page, we are raising money for the wonderful charity Engineers Without Borders. Please come in, donate as well. Although there's only a few hours left, we've got Abbie Smith and coming up Matt Dillahunty, so there's plenty to look forward to and plenty of time to get a few more donations in before the end of the day. Did you have any other questions there, KItch?
Yeah, sure. I know there's one chat question left, but I just want to ask this one that if I can remember it actually.
Well, there was one I had for Abbie. Yeah. It's kind of a little bit off course, but I've noticed, like, see, when you're debating the creationists, do you sense any hostility of them for not only you're a non-believer but also a woman as well, challenging, like, these pastors and things like that? Is there an added kind of tension to that?
When I debated Charles Jackson, I didn't get any of those vibes at all. I think my minor in psychology in college means I'm an expert in this topic here. But I got the impression that he was more interested in himself and more excited about getting to do a show in front of all these people. I think I was there, but I was just a prop. I don't think he didn't mind me in any capacity.
All right.
With Steve Kern, I think he vastly underestimated me, and I don't know whether that was because of my age or gender. I can't attribute those things to him, but he absolutely underestimated me as a debate opponent. I was underwhelmed, to say, like, he's a pastor of this absolutely massive church in Oklahoma, so I was expecting, pastor charm, charisma, the usual stick you get from those kinds of people. And he just, was not prepared. It wasn't a good presentation. And he absolutely got hostile at one point, but I don't know really the root cause of that hostility, other than I was having a great time. I was in a very cheerful mood and just bulldozing over this guy, and he was losing. I think it was more of a sore loser thing than anything.
Is that the one where he said, "I don't know where you get your theology from," and then when you started explaining your science, he just goes, that's wrong," and you're saying, "I don't know where you get your biochem from"?
I don't remember that one.
It was something along those lines.
Yeah. He was the one saying that, he's the truth. He's the only one who cares about the truth. And his truth is, of course, completely fabricated from people who didn't know anything thousands of years ago. But yeah, I wouldn't attribute any of that really to my gender or anything like that.
Actually, sorry, I just actually remembered my question, and embarrassingly enough, it's actually the first point I actually had on my notes. And that's about the West Nile virus. That's actually apparently supposed to be knocking on Europe's door.
Yeah, we've had that in the U.S. for a while. And I'm pretty, there's so many mosquitoes out right now, I'm pretty sure I'm going to get it this summer. I think it's ultimately more of a mild disease than people were initially concerned about. But it's not fun. A summer flu, a summer cold. I wouldn't be too worried about it, but wear bug spray. It's not fun.
It's supposed to be harsher on older people, isn't it?
Yeah, well, and most diseases are. So, as we were talking about before, your immune system ultimately declines as you get older. And so older individuals don't have the immune system they had when they were 18 years old. And so that's why, the saying is if you live long enough, you're going to get cancer because your body loses their surveillance to kill those cancer cells. And so many times viruses, bacteria are more aggressive in older populations because of that. It's not fun. Wear bug spray. Wear the good bug spray.
All right, just to let us know, we're coming up for 15 minutes left, so please keep donating, get those donations coming in. We've done quite well this hour, and like I said, Abbie's going to be adding another $50 for this hour, so doesn't mean you can stop, just keep going with them. Right, I don't know, was there chat room questions there, KItch?
I think there's one I left.
Yeah, you go ahead with it.
Do you think we'll ever see an outbreak as devastating as the Spanish flu again? And that's guest 8828225181.
The frustrating thing is you can't predict that. You just can't. It happens. I think the good news is that we have really good technology today for discovering new viruses. So back when SARS first popped up, this MERS that's popping up, we know how to detect RNA, we know how to detect DNA, we know how to detect retroviruses, and they simply did not have that technology back in 1918. They just knew people were getting sick and dying, and they didn't know why. They didn't have drugs to treat it, and we aren't as in the dark as we were in 1918. So hopefully something like this could pop up, but it would be identified and contained before it became a worldwide epidemic like this. And I guess the good news is for viruses that kill people relatively quickly is that they don't spread, they burn out because they infect lots of people in a set environment. Those people die before they can spread to alternate environments. And so you get these extremely deadly flare-ups, but they burn out. So I would say hopefully no, fingers crossed. But if it does, I do have faith in our technology now to detect it, identify it. And, education is something we can use to prevent it from becoming a worldwide tragedy.
And actually, just on that note, I'm not sure if I asked you this in the last show, but what's your opinion of the movie Contagion?
I never saw it. I usually don't watch virus movies because they just make me angry. And I've heard this one is good and realistic, but they always start with either some scientist who does something stupid, or crazy scientist in the lab doing something stupid, or something like that, and then the science is ultimately frustratingly inaccurate. So I haven't seen it. I have heard it's supposed to be better, but I would just rather watch, Anchorman or something stupid. So.
And actually, just and also on that, what do you think about the zombie movies shifting from a curse to actually blaming it on a virus, like the Walking Dead?
I've mentioned that a little bit before. I also find that frustrating. There are no viruses that turn people into zombies. There are viruses that kill people. So I understand that viruses are kind of this mysterious thing that are useful plot devices because they are so mysterious and creepy. But I don't think it's necessary to invent scary things that viruses do, because what viruses actually do is scarier. So, yeah, I'm not a huge fan of that, but I think that the physicists who can't watch Star Trek because they just go insane with the bad science. I think that's just my problem. If you enjoy this stuff, by all means, continue enjoying it.
Yeah, I don't know if you were aware of this on YouTube recently. There's a guy that we all follow called Miles Power M. I don't know if you heard about this. He got DMCA'd because he did this rebuttal to that House of Numbers movie.
Yeah. Yes. I read about that a bit and
have you actually seen that?
that?
Well, have you seen that alleged documentary?
it is. I think it's probably more frustrating for me to watch HIV denial information or anti-vax information than it is for me to watch creationist information. Many times it is painfully basic science that HIV deniers or anti-vaxxers are either misrepresenting or don't understand. It was actually a anti-vaxxer recently I was interacting with, and she just couldn't believe all the chemicals that were in vaccines. Did you know there's chemicals in vaccines? And I was like, everything is a chemical. Water is a chemical. Like what? But she was terrified of chemicals, and just the misunderstanding of such basic science. It just confuses me and frustrates me. And so with House of Numbers and stuff, it's just really basic science that they don't understand. And science has moved so far beyond some of the claims that HIV deniers make. It's absolutely nonsensical to anyone who actually keeps up with the field and what scientists are actually doing with HIV research these days. And just for the record, anyone DMCAs anybody for any reason that's not strictly someone is using my stuff to make money. Like, this is my stuff. They didn't create it. They didn't ask for it. They're making cash. That, yes, absolutely, DMCA them. But if somebody is critiquing someone's work and they use DMCA to get that critique taken down, I just think it's villainy. It's repulsive. Someone who would do something like that. Yeah, that's my opinion on that.
I would say just with the nature of your blog, do you kind of get a lot of hate mail from HIV deniers?
Not really. I will get like a stray comment here or there from an HIV denier. I will get a stray comment from a creationist or an anti-vaxxer here and there. I generally don't get hate mail. I really can't think of any hate mail I get. I get, a random kooky comment here or there, but nothing bad. Generally what I get are questions from people. They're like, I heard about this in the news. I'm worried about this. Is this something I should be scared about? Or, is this really a cool paper or not? Because oftentimes what happens is a paper, some finding will get lots and lots and lots of press. And then I go and read the paper and I'm like, it's really not that cool. And so that's what I get mostly from people is just questions.
Yep. I'll just ask, so I'm always hearing about Big Pharma. I know there's nothing behind it, but I think a common consensus is that pharma could be improved. It's not perfect, but it is pretty damn good as it is.
And with the drugs, I have no connection whatsoever to the drug side of things. What I know more is the vaccine side of things. And vaccines really are developed by academics in some capacity. They are not people who work for a pharmaceutical company. I'm at a research institution right now working on an HIV vaccine. Ultimately, if we do trials and it turns out really well, Pfizer might buy it, Roche might buy it, and go on to make, they have the network, they have the facilities to worldwide distribute an HIV vaccine, whereas my university doesn't. That's what happens. It's not Pfizer out there generating stuff on their own and faking clinical trials and all that. Like that doesn't happen. There's a huge portion of developing a vaccine that has nothing to do with pharmaceutical companies whatsoever.
Yeah, just the chat room's getting quite amusing. They're listing all the dangers of dihydrogen monoxide right now. So some quite interesting things.
Chemicals. It's just like how do you even address someone like that?
Yeah.
Like, how do you address someone who's terrified of chemicals when they don't even know what a chemical is? Like, that's not a conversation. That's not a debate. That is a proudly ignorant individual with a firmly held belief based on stupidity. And actually, there was a recent study where they gave people different kinds of information to see whether they shifted their position on vaccinating their next child. And what they found was people who are pro-vaccine or had some concerns about vaccines but supported vaccines, they all will vaccinate their next child. It's the people who are anti-vax, no matter what you told them. Even if you, like, for instance, they gave them information from the CDC about how vaccines do not cause autism. They changed their opinion on that. They accepted that information, but they still were anti-vax for other reasons. Anti-vax people were anti-vax, and no matter what you tell them, they're not going to change their mind. And really, that's kind of what you see with creationists, too, like those of us who have interacted with them for a while. It doesn't matter what information you give them. It's not the science they're interested in. They've got an emotionally based opinion, and they're going to keep it.
Yeah, it's like...
what can you do?
It's like I told the team here, my mother, like, I think it was about 10 years ago, she had breast cancer, and then she joined a breast cancer support group. And one year they had the conference in, well, the city I now live. And I went along with her one day to the and I was just absolutely stunned at the amount of kind of new age woo kind of stuff that was going on there.
Yeah. I think that's different. That's predatory.
Yeah.
What they do to people with, I mean, creationism is to a degree predatory in how they take advantage of people's religion and faith for cash. HIV denial is denial. And anti-vax positions, I think to a degree, are predatory on families with autism. But those people who go after cancer survivors or people who are trying to overcome cancer, that's low-level stuff right there.
Yeah, KItch, we're just coming up. We've got 2 minutes left, so I will check the donations, and KItch, you can have the last question for Abbie.
Sure. Actually, sorry. I think I've basically ran out of my questions almost.
That's okay. If people have questions later, they just go to my blog. There's a contact page with my email on it, endogenousretrovirus@gmail.com. If they've got questions they think of later or we didn't get to for something, like it flew past the chat window or something and we missed it.
Oh, actually, I got one from Dimitri. Have you ever played Plague Inc.? That's actually something I actually played myself.
Vaguely. I think I played that a couple years ago for a little bit, but I didn't ever really get into it. But I like those games.
Okay, I think we can wrap up this out. Thank you very much, Abbie, and you came in
thank you for having me.
Yeah, and you came in at quite short notice as well. So, and it's a pleasure to have you back again.
No, it was an absolute pleasure, and good luck with your fundraiser.
Yeah, thank you very much. And everyone, please keep the donations coming in, and we'll be back on. Our last guest of the day, Mr. Matt Dillahunt, is coming up for you. So please keep the donations rolling in, and we'll be back on the air in a second. And again, many thanks to Abbie.
Hi, guys.